So today we're going to start by splitting up section 5.4 into 2 days. Today we're just going to look at arc length. And again, we're doing applications of integration, so it should come as no surprise that we have an integral. So if we start with a function f of x, the first way, and we're told between 2 points, a and b, 2 values for x, to find the arc length. The arc length is just equal to the integral from a to b, the square root of 1 plus the first derivative of the function squared. Now, some of the problems that you can end up with on this are going to be you're not going to be able to compute it easily using one of our antiderivatives. The ones I'm going to work out, we can. So the ones I'm assigning to you are ones that you can work out. However, if you get the integral and you want to check your work, you can always type it into Desmos. And if we have time, I'll show you that in the video. So I'm just going to start by looking at some problems. So first thing we need to realize in this, when we're computing the arc length, we've got y equals 2x plus 1, and we're going from 0 to 2. Yes, I could probably figure this out by just drawing a picture and computing the length between 0 and 2. But we're going to do the calculus method just to get some practice. Alright, so one of the things I need to know, this is f of x. And I need to do the first derivative of this. And in this case, that's really simple. It's just 2. My a value is 0. My b value is 2. And my arc length integral is going to look like this. I'm doing the integral from 0 to 2. The square root of 1 plus my first derivative squared. Alright. And we can go ahead and calculate that out. We got the integral from 0 to 2 of the square root of 2 squared plus 1, which is 5 dx. And this is really simple. That's a constant. The square root of 5 is a constant, so we do the square root of 5. We need an x there, and we're evaluating at 0 and 2. So when we plug it in, we get square root of 5 times 2 minus the square root of 5 times 0. So our final answer is 2 times the square root of 5. And that's our arc length there. Like I said, we could geometrically graph this line and figure this one out because it's a straight line. However, when we have something else, like this bad boy, we're not going to be able to. Alright? So we'll start with the simple stuff. A is 1, B is 2, and we need to find the first derivative of this. So we'll say that f of x is equal to y, and we know what y equals. So f prime, we take and do our power rule. We do 3/2 times 4. That gives me 6, and we subtract 1 from 3 over 2, and we get 1/2. So that is our derivative. And we plug it into our formula. We do the integral from 1 to 2, the square root of 1 plus 6x to the 1/2 squared. So if we do this, we get the integral from 1 to 2, the square root of 1 plus, and then 6 squared is 36. X to the 1/2 squared is just x. Alright. So we can rewrite that square root as the 1/2 power if we'd like. And I want you to see that we can do a simple substitution here. Alright. Of u being 1 plus 36x du is going to be 36 dx. And that gives us an integral in terms of u as 1/36, because I got to get rid of that 36, from 1 to 2 of u to the 1/2 du. And we can keep going. That gives me 1/36. When I do my antiderivative, do my power rule, I've got to divide by 1/2 plus 1, which is the same thing as multiplying by 2/3. And then I'm just going to go ahead and substitute that back in to save some space. And that makes it from 1/2 to the 3/2 power. And we're evaluating at 1 and 2. Alright. So, I can go ahead and simplify some stuff down. Over here, I can go ahead and bring that 2/3 out and times that by 1/36. That gives me 1/54. And then I've got to plug in 2 in here. So if I plug that in, that gives me 2 times 36, 72, plus 1 is 73 to 3/2 minus, and then I've got 1, so 36 plus 1 is 37 to the 3/2 power. And just to simplify some things down, we can do a little bit of stuff here. Number 1, we can put everything over 54. 73 to the 3/2 is the same thing as 73 times the square root of 73. And that's minus 37 times the square root of 37. Alright. So if you want to see how that works out, let me show you real quick. 73 to the 3/2 is the same thing as 73 to the 2/2 times 73 to the 1/2 power. 73 to the 2/2 is just 73. 73 to the 1/2 is the square root of 73, if I can write. Well, that's where I got the numbers from over on the other side. Alright, I'm going to work out one more example. Now, this one's a little trickier, but it's not too bad. Alright, so, again, we got a equals 1, b equals 2. Now this function is a lot funkier than the last one. We got 1/4 x squared minus half natural log of x. So we do the first derivative first. Alright, so I take 1/4 times 2 and get 1/2. Reduce that power. And then the natural log of x, I'm going to do 1/2 of 1/x, so 1/2x is my derivative there. So I'm going from 1 to 2, the square root of 1 plus, then I got all this stuff in here that's squared. Alright, so we got to square this, then we got to add 1, and then I'll show you what comes after that. Alright, it becomes a function with that 1. It makes it a nice thing that's squared, and then we can take the square root away, and it works out a lot easier than what it looks like it will work out. So I square this, I get 1 plus, so 1/2 x times 1/2 x is 1/4 x squared. Alright, I do 1/2 x times negative 1/2x, I get minus, and I'll show you, you get x over 4x minus x over 4x and then plus 1 over 4x squared. Alright, and when I put this together, I want you to notice that my x's will go away. And I'm left with 1 plus 1/4 x squared. This ends up being minus 2/4, which is minus 1/2, plus 1 over 4x squared. And then when I put the 1 with it, I get this nice little thing here of 1/4 x squared plus 1/2 plus 1 over 4x squared. Now, I hope you can recognize that this is also a perfect square with that plus 1/2 in the middle. Alright, so really I've got a square root here, and if I have this, I have 1/2 x plus 1 over 2x squared. So really, this becomes a whole lot easier now. So if you don't believe me, double check my math. I'll wait. Alright, this 1/4 x squared plus 1/2 plus 1 over 4x squared is a perfect square, and you can bring it out like this, and now our integral becomes a whole lot easier, because now our arc length is just the integral from 1 to 2 of 1/2 x plus 1/2 of 1 over x, which is very similar to what we started with, but a little different. Alright, so that looks a lot like our original function when we do the antiderivative, because you're going to see my antiderivative is now 1/4 x squared plus 1/2 natural log of x, and we evaluate from 1 to 2. Alright, and just to save some time and some space, I'm going to go ahead and evaluate this. If I put the 1 in, the natural log is going to be 0, so I just have 1/4 there that I have to subtract off. I get 1/4 of 2 squared, which is going to be 1. And remember, I said I have the 1, so I've got to do 1 minus 1/4, so that's 3/4. And then I plug in the natural log of 2. I can't do that, so I plus 1/2 natural log of 2. And that's my final answer. Again, these exact answers you're not going to get from like Desmos when you do a calculator. However, I think it's easier to go ahead on some of these to work them out like this. If you get stuck, you can get the answer using numerical methods like Simpson's rule, or just using Desmos to calculate it out.